G'day there, and welcome to Weekend's Web App. This is day 2. We're going to be streaming, building a complete web app from start to finish. And as I said, we're on day 2. If you're following along at home and you've got the GitHub repo in, you'll want to check out day number 1, because that's where we ended up last time. And if you check out day 1, you'll be at exactly where we are in terms of the code. Without further ado, we may as well get started. Last time we were working on a simple little routing system, so we'll bring that up and then we'll go from there. Explain where we're at and then go from there. Just npm run, not build, but rather dev. Right, so if we jump over to the web browser and refresh at localhost 8080, so we started off with some really simple little routing. So you can click on a route and end up going wherever it is you like. Now, there are a few things missing in this little setup. So if I click back, you'll notice that the URL bar changes, but not this about link. And the reason for that is because we actually need to listen for when these back events take place. So we may as well get struck straight into that and talk about why that is the way it is. So if we jump into app.ts, just push this over to another window, we don't need to see it. Right, so we had a simple function here where we'd run update view the moment the page was loaded, and we had this little listener for when click events take place. And what that was listening for is whether what we clicked onto was some sort of link, and whether that link went to somewhere local, as in somewhere where this app is in control of. The moment it found that out, it changed the URL with this history push state call, and then ran update view again, which checks the window, the path name of the window.location object, and by knowing that, it knows which view to load. So if we click here, you can see all that's happening, but not our back button events. So we may as well deal with that little oversight first by talking about how exactly that works. So when you push state on, that's sort of one action. When you go back, technically you're on the same page, and the browser knows that technically no page reload happens, so it's not going to force you to go anywhere, but you do need to do something with that information in order to update your view. And the event that gets called when you go back is called pop state. We'll talk about that. We'll bring it up in the documentation in MDN. So yes, the pop state event is fired when the active history entry changes, and that will help us essentially figure out how things are going to work in terms of this page. That'll allow us to go, all right, so something's changed, so now we need to check on our viewing statistics. So what we'll do from here is we're going to add a new event listener for this one. We'll listen on window. And I never really talked about what window is, but window is essentially the global object. Technically every variable in JavaScript has to be attached to something, and if it's nothing else, then that something is going to be your window object. So most of the root level stuff happens on the window object in terms of event listeners and like various functions that you use and that kind of thing. But anyway, we're gonna not digress too much about that and add ourselves a pop state handler. So we don't have too much information here. So these push states will probably show up here as well with this on pop state. So we're going to have to revise this sort of update view component that we've got here. But what we'll do is we'll sort of see how this all plays out by adding some console logging statements and see when pop state gets called, and then go from there. Oopsie daisy. All right, so we've just added our little event listener, and what we'll do is we'll run up our app, bring out the inspector, and let's just see what happens. So when the page loads, pop state doesn't get called. And when we do that, pop state doesn't get called, but when we hit back, it does get called. So it looks like our code will mostly work with the one slight change in that we will need to call update view whenever pop state takes place. That may very well be enough, but let's just see how that goes first. I click about, if I hit back, okay. So really that's enough, okay? So all we needed to do was listen to that pop state event. We might have to add more logic to this eventually, but for the moment, it's simply a case of listening to that pop state event, and when it takes place, we can keep on going. We can update the view because we already know at this point that our window.location.path name, so the thing that we use to get all the information about which page we're supposed to be on, all that information is right there. So we've got everything that we need. So with that little tidbit out of the way, we start to run into what is going to be our main concern for the following hour. And what that main concern is being able to pass routes that are a little bit more complicated than these hard-coded things. Because when you've got a web app, you don't just have routes such as these. You'll have possibly your home route, and then you'll probably have more things on there. So let me organize this differently. Okay, so say we have our home route, and that's just a slash, and then maybe you have an about page or maybe a user profile or something like that. That's all very well and good, but then you'll have some sort of data. Let's say, like we'll just call it entry for now. And that entry, there may be many entries. And in order to choose which one of those entries, you have to have some sort of component within this path that you can then match against. Often that's called a slug. So at least a lot of content management systems refer to it as slugs. So slugs are the bits, so you know how you see in a URL, pretty much any URL, if we pick up a blog entry or something like that, they might have blog and slash this great article, and it's simply just the same text string, but done in a way that's a bit more URL friendly. So they've gotten rid of the capital letters, they've turned the spaces into hyphens, and they've probably stripped any of the punctuation out. So that's sort of a slug, but I mean, it could also be an identifier, and that identifier might be a number, it might be a sequence of letters or something like that. But at any rate, you've got some sort of parameter that is being used to select that particular entry. And that's going to be a common thing where you need your routes. You'll have a series of routes, and let's say, what will we call this? Let's call it article, and again, we've got a slug here. So we've got these series of routes, and we want to have some rules to be able to pick them up. And with those routes, so you'll have a type of route that it is. So what kind of view is then going to be rendered? What kind of parameters you're going to pass to that view? And then there's a bit more logic to go in from there. But either way, this relies on us sort of creating a bit more of an architecture about what is a route and how we're going to match it and that kind of thing. And we also need to make a decision, we may as well, that we'll always have a trailing slash on each of them, because it'll simplify what we're going to do when we write our route parser, as it were. But anyway, that's probably enough explanation. I may as well get stuck into some sort of implementation here. So what I'm going to do is I'm going to build out a platform folder and a routing folder. Because I just want to split out this code ahead of time, just make sure it's working as we expect to start off with. So client, platform, and then routing. We'll just do it all in index.ts for now, and we'll split it out as we need more detail. Right, so the idea of having a router is we need to be able to create a whole range of things that can sort of take care of the picking which function to call or which which view to render, so that we don't have to think about it too much once we're in the thick of developing. So let's think about what a sort of an interface could look like for that. So route path, yeah, okay. So if we have a route path, usually if we look at our index.ts, sorry, app.ts. So we have this view in a HTML. Let's say we didn't want to take any sides with that, and instead we put that kind of concept into a function, right? It was like we're gonna have a function for this view, and it's gonna do whatever we need it to do, and maybe we send it the view element or something like that. So we can send it a container, and then it decides what it wants to do inside that view. Well, if we do that, then we need a render function for our view. Yeah, let's just do a simple render function. And that will expect, let's see, the type for that function would be, that'll be a HTML element. And that's it. We'll just give it one of those for now. So we have this render process, and then we have the path, I guess, or we can call it a matcher. So the matcher is going to be some sort of string that allows it to know what to do in terms of, it'll be a sort of string that allows it to, what's the right way to put this? The string that tells it how to match with any given URL. So let's think about what that format could be for that matcher. So we need to be able to match like simple segments. So whatever text it is or something like that. And we also need to be able to match against some sort of parameter where we say, all right, we don't know what's going to be in there, but we do need to, we need to be able to match against and say, all right, it's got this segment and then it's got this segment. And inside this segment, we want to pull that out as some sort of variable that we can send to the view. So I guess this render function actually needs more. It needs some parameters. And it'll be something like, if I'm thinking about this type, the type of this one, it'll essentially be some route parameters will just be essentially an object that has some strings. So say we matched against this route here. What we would end up doing is we would send the view a HTML element that it can do the inner HTML on. And what we'd also send is an object with slug. This was what the slug was, or something like that. Whatever that parameter is. And if this doesn't make sense, it'll hopefully to make a little bit more sense as we get a bit further into how we implement this. So if we've got this matcher, yeah, we'll do this. We'll just implement it like this, and then we'll go a bit further and turn it into some sort of actual matcher with parameters and that kind of thing. Right. Okay. Now, what we also need is we need a stack of routes. So and what this is going to be is simply a I'm going to take a route path and we're going to take an array of them. So the idea here is that our app is going to need a collection of these routes, which should have some sort of way for us to work towards our function. And this is probably getting a bit too much into pre-designing things. So what I'm going to do is I'm going to jump back to here and think about how we're going to use the code. And like this is, I mean, this is an aside, but for programming, sometimes it's always better to go to the idea of, well, how are we going to use this code? Well, let me think about this. So rather than writing any of it, let's say we had some function called add route, right? And we're going to say with that add route, we're going to go, all right, so whenever about gets called, it's going to allow us to call some sort of, like we want to add a route called about that runs this code here. And that's assuming that it's got a view element here, which is a HTML element. And we don't actually care about the parameters. So in fact, this is more like this. It doesn't, the type signature for this can be more like these are optional because some routes won't actually need parameters. And let's go add another one. And we'll call this one the home route. And we'll pull out the home page for this one. So obviously this is going to look a little icky until we've sort of figured this all out, but let's consider this sort of a simple way that we could approach adding a route. And there's probably more nuance that we need to approach here. I'll talk about that soon. But for the moment, this is maybe enough for us to end up with some sort of routing system. But we do need somewhere to say, all right, what is this route stack going to be? So what are we adding the route to? I kind of like having sort of a functional system about it. So let's say we can create some sort of route stack. Yeah, and it has routes attached to it, just an empty array. And then we send it the route stack. So we're adding the route to the route stack. And same here. And once we've added all those routes, maybe the theory is that we can just initiate the route stack. So maybe we do it even before content loaded. Yeah, before content loaded, we will, we'll just initialize here. So initialize router with a route stack. So say we could do that. We could just initialize that router and actually get rid of all of this code, because now the whole concept of updating a view will be taken out of our hands and in the router's hands. That's sort of my ideal here. Well, I guess we may as well just get about it. So say we were to look at this point here and go, all right, let's say we export a function called add route. We'll see how that usage code goes. We'll have to extract a bunch of code in order to do this. So the idea will be eventually that we won't have any of this code here, and we won't have any of this. This switch will cease to exist as well. And there's a detail I'm missing here, but let's just carry this on a little bit further. So when you add a route, you're going to have a route stack. You're going to have the matcher. And you're going to have the render function. And I'm just going to make an alias for this so that we don't have to keep on typing out that type signature. So type render function equals. All right, let's see how that goes. So we'll take that render function, we'll go view render function. All right, so when we do this, we'll have our route stack and we'll literally just go, okay, the route stack dot routes dot push. So matcher is matcher and render is render function. So for anyone who's not familiar with sort of more advanced JavaScript or TypeScript, this is really simple, but anytime in an object where you just see the name of it, what this is a shorthand for is simply this, matcher colon matcher. So I could technically do that for this render function as well if I removed this. And maybe that's a little terse, so that's nice. Okay, and I'm also deliberately avoiding the concept of classes here. Honestly, I don't like classes in a lot of cases, and I honestly try to remove them wherever I can. If I don't need classes, I may as well not use them. So let's see how we go with that as it is. And I mean, if we ever need classes, we even need a bag of state held around anywhere, then we'll cross that bridge when we get to it. But for the moment, I'm happy to just stick with functions and just simple objects and interfaces, which, I mean, TypeScript is good for that because it does mean it'll enforce me, it'll check whether I make mistakes on this sort of stuff. Anyway, so now we'll go export function initialize router. And it's expecting a route stack. May as well return return the route stack as well. Even though we're mutating it. So what we'll do with that route stack now is we will now have to essentially transplant all of this code into this initialization function. So we've got a few concepts here. The main one is need to know, this is sort of the start of our in-memory storage. We'll end up using something more like Redux or something like that, which will help us manage all of our sort of application state in one place. But for the moment, let's just do something clunky. So let's go current view. That we might not even need that. So let's actually just leave that. Right. So with this concept, once we initialize the router, we need to be able to update view still. We still need this concept of updating a view. So let's actually grab that first. And we still need all of this stuff where it actually calls update view. But at the moment, we've got all of these assumptions that within it, and we need to figure out how to move those assumptions from here. So this route stack, I mean, it's got the routes, but this isn't really enough. So we also need to have, we can probably get away with not moving this, but we definitely need to know what the view element is. And we need to get that assumption out into our application code, as it were. So how about when we're here, we get ourselves a view element. We already know what that is. It's yeah, this one here. We'll just grab that. So we also need to pass that to the route stack. I mean, technically we could, I guess, just put it on the route stack. Just have a little bag of objects there, right? So make that a HTML element. Oh, does it not like that? Why not? View element does not exist on type. Routes any. Oh no, it hasn't caught up to reality yet. There we go. Ah, of course. It doesn't actually have a type yet. So we may as well bring all of that stuff in. So we need the concept of the route stack. We need add route, and we need initialize router. And we need to bring that all from platform/routing. And we don't need to do anything further than that because it's got index.ts in it. And we also need to export this so things outside us know what it's about. Yeah, let's do that. We're in danger of having to put this all inside the DOM ready function, which I'm not a fan of, but we'll get there. All right, so that's acceptable and that's acceptable. Not quite. So we need to make us say that we're going to turn this into a route stack, which is all good. And now the only thing that's not making us happy is that we're not assignable. We're not allowed to assign that function because it's got that there. Well, what we could do we could do this. View render function no params. This is a bit rough and clunky, but sometimes TypeScript you've got to drill holes in it. So now what we've got is a view render function or a view render function with no parameters. And this should make our type system a little bit happier. Why not? It accepts the view element. That's all it needs. Huh. All right. Ah, yes, okay. because I'm not doing a void after. Now it should be happy. Yep. There we go. And I need to clean all this up. So this is now a view render function and a view render function, no parameters. My apologies. Okay, now I've made the type system happy. So what we're going to do from here is we're going to finish up this update view concept. And now when we do the update view, we're actually going to pass it the route stack every time. And now we'll actually work on it whenever we need to do this matching. So you can see here, we've got this update view function and the view element here. We don't need to get that from there anymore because we can pull the view element out of the route stack. So this is another one of those things that's sort of a new JavaScript thing, is your ability to destructure a route, an object. So I can pull the view element out and the routes out. So instead of having to do route stack.view element everywhere, I can just do view element or routes. So that's what I'm going to do. So now that I've pulled that out, so we've got the current location and we've pulled that from window.location.pathname. And now what we want to do is we want to work over all of these routes and see which one of them matches our current situation. So, I want to do a for loop. I don't really want to do a for loop. I don't really like for loops. If I can do things with a function, I almost prefer it. But right, yeah, let's do a sum. Yeah, let's do a sum. Okay, so if we go routes. Sum. So the method of sum allows us to essentially keep on iterating over a collection until something returns true. So the idea is that we will work over all of our routes. So this is a route path. We actually already know what that is, so we don't need to type it. We're going to work over our route, and we're either going to return false, which means we didn't match, or we're going to return true. And if we return true, then that's when we're going to actually render the view. We're going to run this function, whatever it is. So let's say we just do the bare bones basic and just get something running. So if a route.matcher equals current location, see daisy. If route.matcher equals current location, then we should be able to route.render. Yeah, we render the view and we use the view element while we do it. We don't give it any parameters because we don't need to. All right, and then we return true, so it doesn't go any further. So this is probably a good time to stop and actually check that our assumptions are right. Okay, everything seems to be building right here. So let's run our page and see what happens. So nothing happens currently. So we need to figure out why that is. So we're initializing the router and we're running update view and nothing seems to be happening. So yeah, let's double check all of this. Like essentially we'll just check. In fact, we'll step it in the code because there we go. So we refresh. So we do get here and then step through. So we do have the view element and then we jump into the next function call. So I'm just following the code, seeing what's happening. Nothing got updated when update view happened, and then these function calls happen. So I probably want to just check out things here again. We'll refresh. And if we move down here, okay, that matcher didn't match. So we're at this matcher here, which is the about. Right, we're not accounting for the trailing slash. That's of course why it is. So we've also got to deal with that little case. And what we might do is in update view, what we can do is within update view, we can do a little redirect pretty much every time we end up in here. If there's not a trailing slash at the end of current location, then we're gonna fix that right at the heart of it. So we'll check if current location dot length take 1. So this is defined the sort of the last character, and if that does not equal slash, then we're going to pop push state. This is a very rough fix. I do grant that, but it'll do for now. But if we do something like that, we will then have a new path name with that slash on it. So we can let that, and then we'll rebind it if that's the case. Because push state is synchronous as far as I'm aware. Right, okay. So if I, let me get rid of these debugging statements. All right, lovely. So if we get rid of that, if I click there, you can see here it pushed on that last thing. And if I go back, it's not going to let me, which is sort of weird for that redirect, but it should only happen whenever people end up on the page. And then after that, things should sort of behave as expected. That will break back behavior though, because I believe in my text, I haven't put the trailing slash on. So we'll have to address that at some point, because eventually we're not going to want to have to create all of these routes sort of manually. What we're going to want to do is call some sort of function that says, hey, give me the named route for this particular page. But at any rate, that does technically work, but we need to keep on going and building this up, and we should be able to still go to Google, which we can. Good. So we've made no progress, but we've altered the structure of our code somewhat. So what next? Well, let's get rid of, while we've got a moment, let's get rid of the fact that we do in fact have problems where if we call our route stack and we, if we call our route stack for some sort of, if we just write in our name here, what our route is, that doesn't necessarily give us the route. Like if it's off or something like that, we can have a typo and that could be a problem, right? So what if we gave all of our routes names, and then we used some sort of function to get us there instead. So say we had a function here that instead of doing this, we could call it and go, all right, get route for name, right? Unfortunately, we also need to pass the route stack, but that's cool. Let's say we did that, right? It's a bit wordy, but we will deal with the wordiness soon, right? Or rather, we will deal with the wordiness with some sort of wrapper down the track. But for now, let's say we get route with that route stack, okay? And we'll actually make it, instead of get route, we'll make it get URL, because that's really what we want to get. We want to get the URL based on some sort of name. Alright, so that just makes the type system happy here, but we also need to figure out what we're going to do with all this stuff. So we're going to collect ourselves a name for the route path. And then we're going to go and get that name at some point down the track. All right. So now that we've added name to the route stack, we can have this little function that allows us to find whatever that name is and then turn it into some sort of parameter, right? So let's just say, we go over all of the routes. So if we pull out the routes of our route stack, we pull out the routes of our route stack, And then what we're going to do is iterate over them until we find something. Once we found that something, that is the thing that we are going to return. Gosh darn, I don't even know. Does array have a find? It doesn't have a find, I'm pretty sure. It's been so long, and I'm resisting the temptation to use a utility grab bag like Lodash, just so that we can avoid it and actually end up writing code where we can. But we do have find, but it's the first in. Oh no, we've got a find. That's good. Yes, so we want find. So matching route equals routes.find. What's the compatibility on this? Because there was a time when I wouldn't even bother using it. No IE support. That is the thing. I'd need a polyfill for it if I was to use it everywhere. But that's all right. How about we just use it for now? We will we'll pay back that technical debt down the track. So we want to find a we want to find a route. We got a route path that matches the name. So this is. So all we're going to do is return route dot name equals name. And what that will do is that will give us back routes.find. It doesn't have it either. So we might have to implement our own function to keep TypeScript happy as well, rather than rely on the polyfill. Yeah, well, a polyfill wouldn't be too hard work, really. I mean, I could just do it rightified function. That would work. Didn't really feel like reinventing the wheel straight off the bat, but we're probably going to have to do it if we're going to do this without a library. So let's just get it over and done with. What am I doing? Client and platform. Yep, and we will put in utils. We will put our find function. We'll just have an index utils for the moment. Right. So to avoid looking like I'm rambling, essentially we need a little function that gets us the first thing that we find. And unfortunately, because they don't implement it directly in this, I'm going to have to write it myself. But it's not super hard. All it's going to do is run for all of these testing functions, and once it finds the first one that gives a positive answer to that testing function, it'll then return it. So a function find, export function find. So we're going to make a find function that takes an array of pretty much anything, and so any array and then returns anything. Now I'm going to change that to be proper types at some point, but for the moment that is our type signature. Right. So what we'll do is we'll just run a for loop over it. I don't write these enough to really remember the syntax off by heart, but I'm pretty sure it looks something like this. So which one's the condition? This is so embarrassing, but I always forget get these mixed over. Yes, of course, it's the condition and then the iterator. So the idea of the for loop, you initialize, you have a condition that checks, and the condition in this case is array.length. So while this index number is lower than the array's length, we will keep on going. And then what we're going to do is we're going to check over every single one of these items and run some sort of testing function. So that's the other thing that's here. So test func. So that testing function will accept an any, or rather item any, and then return a boolean. And I'm hoping I'm writing this type signature, right? I am. Okay, so if test func array, so just for the sake of making it really clear, we get the array index, and then with that array index, we're just going to test whether or not it's truthy, whether it returns truthfulness on the function. So we just feed it to the item, and I guess we can feed it the index in case. It doesn't really have to do that, but I'd say that's optional. So we feed it that, and if that's the case, then we return true. If we, or rather return that item, and if not, we return null. So we didn't find anything, and that should pretty much do it for us. So we will now grab that function for us. So we're going to import find from utils. Always turn off your notifications, eh? All right. So now, if we run find on routes, we should be able to get that matching route. And then if we find a matching route, if we find the matching route, then we can return a matching route.matcher for now, but we'll have to do something more complex than that eventually. Else, we will return 404 route not found, and this is just to make it really clear that something's wrong, because it really shouldn't get to the end without finding anything. And the other thing we can do is we can put out a console warning. Yeah, route not found. What's the name of this one? So yeah, we'd get that. So route named not found, and the name is name. So if we put that warning out there, then we should be able to know when we're doing this wrong. So just so we don't get too far ahead of ourselves, we're going to run this function just so that we can see what exactly I'm going on about here. So route named name not found. Okay, because we don't have a route named name, but what we do have is a route named about. So let's try that. Okay, so now it didn't complain, but it returned object, and that's because we returned matching route instead of matching route.matcher. So let's try that one more time. And now we see that we've got our about there. And that way, and this is very important, this decoupling is pretty important, because what it allows us to do is do things like change about the app. Let's say we changed that route to about the app, and we refreshed, and we can now see that about the app becomes its place. Okay, so by decoupling that and just giving it a name, we're allowing us a little bit of flexibility, just a little, but not a lot, but just enough to give us some flexibility. Now, next up, we'll make use of it down here. So we'll do this same get URL using the route stack, and instead we'll be going to home. Same deal, all still working, all great. Okay, we didn't actually get as far as parameters yet, and considering we've got 15 minutes yet, I don't know if we'll get there, but we'll try. So in terms of getting to having parameters now instead of just a more complicated way of rigging up all what we had originally, which is we're not getting any simpler yet. So we want to try and get to a point where, well, simple is not the right word. We're not actually getting any additional functionality yet, is what I meant to say. So we want to have additional functionality. What we want to have is, let's say we have a concept of an entry. We want to be able to write it such that say we had the concept of an entry page, right? And that entry had some sort of slug or something like that. I see things that often use a syntax like this. So let's say, yeah, we use slug as the parameter there. And what we need is for our system to know that this is not actually what we want. What we want is we want that to be changed with some sort of parameter, some sort of string. So let me go a bit further than that and say that in here we would have some sort of parameters, and that parameter would be, yeah, just key string. So I can pretty much call it any. And then what we want to do is we want to pull out slug from parameters. And we could use that here. So we could say, all right, let's just put the slug in the head, right? And then have some way to go home. All right, now if we refresh, I mean, our code will work. Well, not that code because that's a 404. But our code will work, but we won't be able to do anything with it yet. And if we were to put some links, say in the home page, let's say we had this is a UL, which is an unordered list. Let's say we had an unordered list and we wanted to put a series of links in there. So let's say we've got an A, href, and instead of going to the about page, this one's going to go to the entry page. We would want some sort of syntax that looks like, where we have the route page, we say entry, and then finally we say that the parameter for slug is entry1, say. Yep. Alright, it's not going to like that because it's got an extra argument, but let's just continue despite the screaming. And so now we need, like, if we want to use it like this, then the type system is now telling us, well, we haven't actually dealt with that case yet. We don't handle this. So now let's do exactly that. Let's handle it. So we will go into our routing. Routing. And now we need to get those parameters. And that's just going to be some object with key string, and string. That's pretty much it. So let's say parameters. And we'll do the same thing. In fact, I'm going to get real tired of doing that. So let's make a type for it. Okay, and now, if I change until there, that's going to be it. Okay, and now I can go here, do the same deal. So now we've got this concept of view parameters, and that's optional because otherwise all the other functions will complain. So if we've done that, now that's going to clean up. It's fine with that. It's cool with that. But if we look here, we'll see that our entries, you can see there, where it has the colon slug, nothing actually changes. So it's not yet there. So we need to have some sort of function that breaks these apart and then figures out what to replace all of those components with. So let's do just that. Now, as an aside, because it's 10 minutes before the end of stream, before I start taking questions, I know apparently there was a question last stream, but my chat broke or something like that. I've just refreshed my chat, and if there are any questions that anyone has, please feel free to throw them in right now, and I will get to them when we get to the end of the stream. If I don't notice them on the stream, please at me on Twitter, because I've also got that going on another tab. All right. Anyway, back to the task at hand. So we want to deal with this slug, and let's think of a really simple way that we could do this. So we've got the concept of this matcher, And what we want to do is we want to break it apart and then find which of these are like parts of the parameters and then return them as a sort of a slug. So let's say that we do that ahead of time. We just do something really naive. So we've got the right matching route here, and what we need to do is break it apart and find anything that's a parameter instead of anything that is a parameter instead of just a hard-coded letter, number, whatever combination. So if we go segments, so what we'll do first is we'll take the matching route dot matcher and we'll split it up. Split it up like that. So if we're just going to run the concept here, so something that has entry slug. In fact, I don't want to be doing that. Something that has that. If we split it by all the slash components, will look something like this. And these are fine. We can sort of disregard them, and we can just work through them. And any of the ones that have themselves a colon up front, we can then do some additional logic with. So let's do something like this, where we pass the segments by taking the segments and running what's called a map on them. So the concept of a map, it's a little function that will do something to each one of those things, and then we will end up with a new array that looks like it. So let me demonstrate that real quick over here. So if we were to run a map on this function, on this array here, this 1, 2, 3, 4. Say the array, the map was number plus number times 2. So the returned array is each of these values with that function run on it. So 2, 4, 6, and 8. All right, we're going to do the same thing. We're going to run a map on it. So we're going to go past segments, and we're going to go segments.map, which we know are strings. Okay, so if segment, so if there is a segment, like there is a character in the segment, and segment 0 equals, then we need to do something special with it. Otherwise, we can just return it. So here we just return the segment, and that's all good. I don't know, how many times can I misspell return? So we take that segment, and technically that'll work. So let's say for the moment we'll just go past value here, just to take it real slow. And then finally we return the past segments joined with that slash. So we put it all back together again. And what you'll see here, so you can see if you look at the URL down at the bottom left, or even if I click on it, you can see we went to entry/path value. Well, I mean, that's not quite there, but we're nearly there. Now what we need to do is we need to take the parameter, one of the parameters, and put that right here. So what does that look like? Well, that looks like params segment, like a slice of the segment. So if we've got this string that is slug, we just want the slug bit, right? So we could get that by running a slice on it. We could go slice 1, which means slice from the number one number one point of this array. Because of how computers do numbers, 0 is the first one, and most of the time 1 means the second one. So we want to slice that segment. So segment.slice number 1, and that will give us exactly what the parameter was. It might not find it, it might run into problems. So what we could do is if it can't find that one, we go parameter not found. Yeah, and what we'll do is we'll add ourselves some error checking here as well. So segment param equals and this is assuming that this is not optional as an aside. Like if it was optional, then we'd have to figure out something else, but let's not deal with that case. So right now, if the segment parameter is this, then we can go, all right, const, yeah, if the segment parameter is here, then we can take that segment parameter. If the segment parameter is there, then we can just return it. Yep, and otherwise we'll return parameter not found, and we'll spit out an error. Or a warning, rather. Route named thing is missing a parameter. Yes, yeah, it's missing a parameter called segment slice 1. So just to show what that error checking is meant to be doing, it's not going to do it here, but say we were to accidentally mistype one of these slugs. FG instead, and we refresh it, you can see route named entry is missing a parameter slug. So, and then we'd have to track it down or something like that. But the good thing is you do get stack traces when it comes to warnings. Console logs don't necessarily give you stack traces, but warnings and other stuff always do. So we can probably track all the way down to this routing function here, not that one there. Initialize router, where is it? You can see here, we can track all the way to the call that didn't actually give us the information that we needed. So there's just enough information there in that stack trace for us to do what we need to do to fix the problem. All right, so we've gotten to a route system that allows us to sort of decouple all of that sort of stuff, put it into a particular area so that we don't have to worry about it too much. We are still missing the last piece of the puzzle before these parameterized routes work though. We need to be able to match against whether it has, like, whether it structurally fits, rather than whether it just fits sort of like a matcher does. And at the moment, we could probably do this a slow way and then eventually do it a faster way using compiled regular expressions. I want to see if I can match this quickly. So yeah, let's see if we can do it. So what we've got here is we've got this concept of a matcher, and what we probably want to do is we want some sort of function that turns into a matcher, or rather, it contains all of our logic for matching a route. So match route to path, or path to route rather. So let's say path is string, and matcher is a string. So, like, if we were to have our current logic, it would look like this, right? So path is this, and matcher is this, and they equal. Great. Mission accomplished. Not very good at mission accomplished, but it is a mission accomplished, right? So match path to route, current location, and then the matcher. Route.matching, my apologies. All right, so this will get us back to not having changed anything, but we still can't get to the actual entries. So what do we do to handle that problem? Well, we need to pull this apart and figure out whether it structurally matches rather than whether it actually just has straight equality. So one way we could do this without going down the route of regexes, regular expressions rather, is we could break it apart, check the length, and then check that everything that isn't a slug matches, and then everything that is a slug is present. And that will probably do, actually. So let's try that simple concept just to start off with, and we'll see how we go. Yeah, so we've just hit the 5-minute mark, but I think this will only take say 5 minutes. So yeah, I think it'll be fine. Let me take a quick drink of water, and then we'll slam it through. Okie dokie. So if we take the path, so what we'll do is we'll so path segments equals path.length. Split, and then matcher segments. Matcher split. Now, if path segments dot length does not equal matcher segments dot length, we are already a no-go. We know that we can just pull out because an early return, because we know that there is no way that is going to match, because they're just not the same length. And then after that, what we can do is we can run a function called every. So we go path segments dot every. Yep. And that's a string, and then an index. And I don't actually need to put those types in because it already knows what it's going to look like. So that function of every, it's only going to ever return true as a whole. So this whole little block here will only ever return true if all of these elements return true. So if any of them return false, then it's all 100% false. And what we want to do is we want to check over every one of those segments and check them against the match segment. So const match segment equals that match segment is matcher segments by x, and then we need two different types of checks here. So if match seg 0 and match seg 0 equals colon, then we need to essentially just accept whatever the path is as long as it's longer than 0 characters. So here it's just simply return path segments or path seg rather dot length is greater than 0. Because as long as it's greater than 1 character, we can be relatively sure that we've got enough information there, right? Now, if it's not that, then all we need to do is return an equality check, because if it's not a path segment, then we know that the string just needs to match it. That's all it needs to do. So if return, otherwise we just return path seg equals match seg. And now if we do that, in theory, oh, it didn't like that. Why didn't it like that? What did I do wrong? Param slug. Oh, it already tried to load the route. So we've already hit one problem, but that's okay. So it unwittingly worked, but this function here, it's missing the parameters. So when we update our view and load the new view, so here this render function, we actually need to get the parameters to it. So if we just passed it this, just a blank object, type system doesn't like it, but anyway, technically it worked, but it's undefined, right? So it doesn't fully work, but it does kind of work. But what if we were to say, in addition to this match path to route, what if we were to return some view parameters? maybe that would work, right? So say we have some view params. So if true, here we go. So now const matched equals. So now instead we check if it's matched. So here, where we've got a match here, what we do is instead we add it to an object for match parameters. So we'll go match seg slice 1 to get that perfect perfect fit, and put parseg on it. So if it matched, we return the view params, and if it didn't match, we just return null. And granted, we could do this in a slightly terser way, but I'm just going to hold off on refactoring down to something a bit smaller for a moment. So let's say we change this up. So now we've got those view params here. Expected 1 argument but got 2. That should not be true because you should be able to accept both of these. But I guess because it's a union type, it's like I can accept either. I wonder what the best way to put this is. Maybe if we just go view render function with that type. Will that? Yeah, that'll quiet it. Okay. So now, if with any luck, this should actually work. Yeah, so we've got entry 1 here. Go back home. Entry 2. Entry 3. So with that, we've put together some really simple route parsing. It's not, I mean, it's probably not the most performant of setups. Not that route parsing happens super often. So it's not really the place where you're going to end up getting big performance hitches, but it does have to iterate over every single path. So maybe it could end up being a bit heavy down the track. But at any rate, we've got some simple route parsing. We've sort of broken things out a bit so that we don't have to... Yeah, we've broken things out a bit so that we don't have to think about that as much when we're writing our code. And eventually, we'll probably try and get rid of some calls that mean we have to call the route stack or anything like that. But for the moment, I'm sort of happy to... We'll keep on polishing this stone a little bit further because there are some concepts that are missing in terms of routing and like rendering these views and stuff like that. But for the moment, we're getting somewhere. But for the moment, that will probably finish us off for day 1. Let's say day 2, my bad. I did say I did ponder getting down the route of tests, but I haven't. We'll probably set up some basic testing next day, because that'll give us a bit more room to play around with this and make sure that we're not breaking things as we move through it. So we'll wrap up day 2, having created a route parsing, URL rendering, and route parsing and matching. Yeah, that'll do. So I'm just writing my commit message down. We'll send that back off to GitHub, and we'll pretty much wrap it up there. Yeah, so I mean that actually went in a slightly different direction than I sort of expected it to. Like I have built this stuff before, but I'm trying to approach it with a sort of open mind, figure out how I can build from a sort of a base perspective, and only put in the things that I absolutely need rather than overbuilding it too quickly. But either way, I'm fairly happy with how much we've built up here in terms of the routing concept. There is a lot more complexity that we eventually need to visit, like what happens when you end up somewhere where there is nothing. it should probably call show some sort of 404 view. What happens if an error happens while it's trying to render that function? It should probably tell the user so with some sort of 500 or server error or something like that. Some kind of message that says, hey, something's gone wrong and we need you to go back. And that's sort of where there's going to be a lot more complexity in these view layer functions rather than just a simple function that calls view in a HTML and then does its thing. But we will eventually get to that. We just got to slowly build our way towards a fairly solid system that we can reason about and work through. So that's pretty much it. If there are any questions, I will check on Twitter and I will check. I've got nothing on my chat, so if there's anyone who's asking questions, please at me on Twitter if it's not showing up anywhere else. But I have this feeling that we are just about done for today. Yes, we are. Okay, so if you've been, thanks for watching. If you've watched this belatedly, or if you're here right now, thank you very much for watching. We will be back tomorrow at 8 p.m. Australian Eastern Standard Time, and we'll be carrying on with our routing system. We've got no reason to stop. We'll add some tests in. We'll start to handle things where the whole parameter where the route doesn't get found or anything like that. So we need to figure out how to show 404 views and all that sort of thing. But we'll be getting into that next time. For now, thanks for watching. I'll see you next time.